Hello, community. Here we look at the code of a single agent. Say hello, agent. Yes. So before we enter the multi-agent interactions, we have to be able to code the single simplest agent. So we say import OpenAI, yeah, and then we have a Python class. The easiest thing you can imagine, we have a Python class. This Python class, what we have here again our API key. We have to pay OpenAI to use their tools, their models. Then we have here a list, if you want, where we have a conversation history, a simple string where we can append here different text messages. And then we have here the function add to conversation. This very easy, as I told you, takes a string and simply appends here the textual message to this list in a string format. And then we have here to generate a prompt where you say, for example, the following is a conversation with an AI playing the role of whatever role you want to define. And then, of course, you say here the prompt is now added to the message. And then we perform a very specific task. And this here is our task. Now, what you do is you add it again to the conversation. You generate your prompt. This is the function just above here. And then you have here the OpenAI completion API endpoint. Please note that this here is just the simple OpenAI completion API endpoint and not the advanced OpenAI chat completion API endpoint that we will use for more complicated function calling later on. So here we are at the most simplest examples. So we go at text DaVinci 03, the model that we like. We have our prompt, we define maximum token, whatever you want to pay. And then, of course, after this, we want to add again the response here of GPT-4, the text that has been stripped for non-specific characters here to our conversation. And we return, of course, the response here, the text. You see, this is the simplest conversation agent, a Python class you can think of. It has, if you want, some local memory because it records the complete conversation on a specific topic with, let's say, GPT-3 or whatever. Now here, text DaVinci 03 is our model that we're gonna use. And we have here the OpenAI complete create API endpoint that we're going to use for creating an answer from GPT-3. Of course, you can do this here in a simple prompt if you just type to GPT-3, but we use here this specific Python program to create a conversation agent. Beautiful. Simple example, yes. If you want to experience how to code here function calling with agents, I have shown this in my last video, and this here is HPBS link. Now, a real agent could be much more complex with additional logic for interpreting the response of GPT, managing multiple tasks, interacting with other agents. So let's now enter a little bit more complicated scenario where we have two agents that interact. And we make a very easy two-agent scenario. We have a user agent that represents, for example, a potential or simulation of a user. And we have a help desk agent. And you're not going to believe it, but it represents a help desk assistant. So what is the task? The user asks question and the help desk answer the questions by the user. Unbelievable, you're going to say. I know. So how we do it? Again, is example class, Python class here, our user agent with the API key. Remember, every agent, you have to pay for every agent for every API. And we have here the function ask a question, and we have here the question by the user. And then we have here the class of the help desk agent. And you see it's a little bit more complicated. And we get a response back. So beautiful. So let's have a look here at what methods we have defined. So at first we have here our local memory. Everything that we have as a question and comes back from the system. We record here the conversation history. So we have a complete information of the local timeline. Then again, you notice generate the prompt and add it to our conversation history. So you tell the system, hey, the following is a conversation with a help desk AI. And now comes, if you want the first logic part, we say, hey, if something happens, then do this. So if, then, if you want. So this method here would contain a logic to escalate the issue, such as sending an email to a human operator if a particular instance happens. For example, it could be that the GPT-4 system comes back and say, hey, I don't know. So if you get the wording, I don't know, you say, hey, careful issue, there's an issue, contact here a human operator, send an email, send a bing, whatever. And then, of course, we come here to the most important task, to answer as a help desk the question by the user. So again, you add everything to the conversation, you generate your prompt. Again, we have here our OpenAI complete API endpoint that creates now the answer. Here we have max token is 100. We have again our text DaVinci 003. We have our response, we have the choices. Please see my last one. We have the text that comes back, and this is the response of the AI. And we add this, of course, to our conversational memory if you want. And if, for example, the response is, as I told you, this particular wording, hey, as GPT-4, I'm not sure, or I don't know, or whatever your trigger words might be, you then have here the escalate issue command where, for example, an email is sent to a human operator or whatever you have in mind. Beautiful. So we have our user agent and our help desk agent now defined. So now we more or less create them, we initiate them. User agent with your OpenAI API key, so your credit card says, hello, I'm here, baby. And then again, with a help desk agent, you have again your credit card operational. Great. And then you simply have the user agent ask a question. And now I put here the question directly into here the string. How do I reset my password on my computer or whatever the help desk is? And you have the question, and then you activate the help desk agent with the question answering functionality given my question as a user. So you see, and you print the answer by the help desk. Great. So GPT-4, let's say this is our LLM, answer now, how do I reset my password? I suppose GPT-4 knows the answer. Now, if the user comes now with a question, what is the meaning of life, that is not for an IT help desk situated, and you know, yes, we are now here that we say we escalate the issues. We get now here this particular question, and the help desk agent tries to answer this, but escalates the issue because it is not sure, being an IT help desk, what suddenly this philosophical something means for him. So yeah, we have now this trying of answer and that escalation step. Here we answer question, and here we have our escalation step. If, for example, the response is I'm not sure, whatever is your trigger word. So you see, this is now an example of a more complex interaction between a user agent and a help desk agent. Now you say, okay, this is a 2 agent, let's do 3 agent. Let's do a discussion between 3 agents. I say, great. So we have, and now if you notice, we will only have 2 classes but 3 agents. And I want to show you this particular example because how you can reuse your agent definition. So we have a negotiation agent class in Python, represents an agent that negotiates a deal. And in the middle between 2 parties, we have here a mediator agent class. That is an agent that helps facilitate the negotiation between the 2 parties. Beautiful. We will see we have the method negotiate, and we have here the method mediate between those parties. Main script, yes, yes, yes. Now let's jump into the code. So at first we have here the class of the negotiation agent. You now know, hey, open API key, your credit card waves and says, hello, I'm here. And then you record your conversation history. Beautiful. You add this to your conversation, so you have a local memory of the complete conversation. You generate your prompt, you add it to the message, you know this. And now comes the part negotiate, the method negotiate now for our agent that does the negotiation. You add it to a conversation, you generate the prompt, you have now the OpenAI completion create and API endpoint. This is your engine, this is your prompt, your maximum token is whatever you define, whatever you're ready to pay. And you get back a response from ChatGPT, let's say. Choices, text. You add this to your local conversation memory, and you return the response by our AI system, our LLM system, ChatGPT, for example. Beautiful. This is the negotiation agent. And then we have another class, our mediator agent. You're not going to believe, more or less the same. So yes, you can read it yourself. I don't have to go through this again. But here we have now here the method mediate. Remember in the other one we had here the definition negotiate, the function negotiate. And now we have mediate. But it's the same. It connects to TextDaVinci 03, gives it the prompt, and we wait for the answer that TextDaVinci comes back with. Great. You can insert any LLM that you like. So that we have the definition, now it's time to initiate our 3 agents. And now you see we have negotiation agent 1, negotiation agent 2, and they are both the same. We use here the coherent definition of a negotiation agent. We will just provide a different statement or a different task or a different opinion or whatever to differentiate between them. And you're not gonna believe it, a party 1 and party 2 is here, our differentiator. And then we have our mediator agent. Yeah, and if you have not provided here our credit card, we provide a credit card for the agent. So you see, you have now, if you want, 3 instances that connect to GPT-4. And you pay for each instance. So I have here now a very easy interaction pattern. And I always put here the answer here into the parentheses. So we have the negotiation start. Agent 1 says, hey, I want to buy 100 units of whatever at $10 each. And this was the buyer, and the seller says, hey, we can only sell 100 units at $15 each. Great. And now the mediator comes in. We have here our mediator agent with the method of mediate. We have here the input of agent 1 and of agent 2, and you're not going to believe it, the response by GPT-4 or GPT-3 or ChatGPT or whatever system you have, if they say 10 and the other party has 15, now they gonna use, you're not going to believe it, as a mediator proposal, $12.50. So they meet in the middle. And so beautiful, this is now the, let's say, proposal by the mediator agent. So the first one asks the other agent, hey, can we meet in the middle at $12.50? And the other agent is reasonable and says, let's agree that we meet at $12.50. So you see, unbelievable performance. And if there would be some problem, you just call here the mediator agent again. So let's call it GPT-4 again, and let's see what GPT-4 comes up with a possible solution that we present then to our agent 1 and agent 2 in their negotiation, if they accept it, if they reject it. But always remember, the intelligence behind agent 1, behind agent 2, and behind our mediator agent is always GPT-4 from OpenAI. You always connect to the same LLM, just here with 3 different instances. But it is always in the background GPT-4. Just to make sure where the intelligence lies here. Great. Now you might have seen that sometimes agent can create for specific purpose, from specific period of time, new agents, new sub-agents for a very particular task that is absolutely focused and you need a specialist. So I said, can we further increase the complexity with 2 agents? Now can create temporarily another agent to perform a very specific task. So you see now we have an agent hierarchy integrated now in our next coding example. To make it easy, I just operate here with one main agent and one main sub-agent. Otherwise, it would get a little bit complicated. You know our class now in the sleep. You know that you have to provide your credit card and you say, yippee! And then you have your prompt. And you say, hey, GPT-4, please perform the following task. You define the task. You have your completion API. You define your LLM and you get back a response by GPT-4, let's say. Great. So now we have here, this was the task agent for a task. Oh, no, don't do that. No. Okay, I shifted this. Oh, can't believe I've done it. And then you have the control agent class. Now this is our supreme agent. This is here the boss. And he can create and manage other agents. So we have now here with this Python class control agent, yes, we have our credit card ready. We create here an agent, and this agent now is a task agent. So our control agent here creates now a task agent. And the task agent has been defined over here. Beautiful. And this control agent has now another functionality. This is manage a task. And in this function, they can now set here to create an agent. And this new agent that is created can perform a predefined task. And this sub-agent gets back a result to our control agent. Beautiful. This is the definition of our two agents. And now we create here the master agent. Yes. So a control agent, and you have your credit card ready. You say yippee. And then you say, the control agent manages now a new task. And for example, it is itself not able to perform the task, but it has defined here another agent. So you say control agent manage the task. Now here language translation, English to French, for example. So very easy. You see here control agent manage task. So control agent manage the task. We create here a very specific agent. Let's say the task is now to translate languages. And you say, okay, perform the task. And so GPT-4, the intelligence in the background, is now performing the task to translate an English text to a French text. Beautiful. This is it. This is all there is to it. Now, of course, this is kind of a simplification that I show you the flow, that I show you how it works. Is this the absolute complete code with error correction and everything? No, this is a simplification. Therefore, I leave you two links in the description of this video. One is the link to the official OpenAI cookbook. And this cookbook, I can show you here. You go there, OpenAI Cookbook, examples, how to call function with chat models. This link here, you can download it. You have beautiful real-time examples in the full complexity. But sometimes if you read this the first time, you might say, oops, what's happening? Therefore, I showed you a little bit simplified version with no error correction, with no other objects in place. But this is here the notebook. Download this notebook. I leave you the link in the description. And then if you're really that you say, hey, now I'm no, there's also an expert notebook that I will leave you the link in the description. And this is also in the examples. And this then here is function with a knowledge base, for example, with articles, summarization, or you have here a conversation with a PDF, for example, a scientific paper in the archive. This is a preprint. Normally it's not a peer-reviewed paper, but a preprint paper, a scientific paper. And you can have now a conversation with this. And here with our multi-agent, it is possible. And here you have the complete code here in this notebook. You can download for free. This is here the GitHub. I will leave you the link to this in the description of this video. Beautiful. Yes, you might ask, why do we create agents? Why is this necessary? And hey, we have not used any link chain at all and everything. Yeah, this is the beauty of this system. So, but come back, additional agents from a control agent. What is the benefit? Now we are thinking about how we can configure our agents, how many agents we need for a specific task. So what is the benefit of have here a control agent create other agents? Now, at first you have a task specialization. Each agent can be specialized to perform a scientific task. You have seen that I used the agent definition for our negotiation. One a negotiation, two agent. Okay, if you have the identical task, you can do this. But maybe your task specialization is very dedicated. You have to have different subtasks or different access to different external APIs. So you can build here an agent for a very special task. And this agent will only be able to perform one task and one task only, but highly specialized. The next thing is here parallel processing. If the task can be performed in parallel, you have multiple API IOs to your system, multiple API endpoints you can contact. They perform in parallel. Creating separate agent for each task can speed up the overall process performance significantly. You don't have to wait. Of course, if you have logic dependencies, then you have to wait. But if you have resources where you aggregate information from, do this in parallel. This is where agent and sub-agent come into place. Each agent can work task independently, and here a control agent can collect the result. Resource management. If each task requires a significant amount of CPU, GPU, whatever, create separate agents here so you do not reach the maximum bandwidth or whatever compute limitation you have. And the last point is really important. If one task or subtask fails, if you have multiple agents or sub-agents, it won't affect the whole chain of agents. So each agent can handle some errors in its own way, and the control agent can decide what to do if one task fails. You can define it in the definition. You can do a retry, you can log the error, you can escalate the issues, you send an email to a human operator. Whatever you have, there are advantages to use here a modular approach to agent and sub-agent and assign specific tasks to their intelligence. But whatever you design the task force, remember an agent just more or less connects to GPT-4, a specific LLM, an external API, an external database via API. But the main intelligence, if you want, is still GPT-4 or ChatGPT or whatever LLM system you use. So do not make the mistake to think that you have multiple different intelligence here on the line. No, you're just probing in parallel GPT-4 or ChatGPT. An example scenario, yeah. What are real world scenarios? I was asked, show us some real world scenarios where a multiple agent makes sense. You're building a news aggregation service. You have a control agent, manage the complete process. And it can create separate agents for each news source. I don't know, you have social media, you have print, you have video, you have whatever. Different format, different conversation rates, different whatever you can imagine. So each agent is responsible for fetching the news from its particular formatted source, parsing the news articles, and storing them in a database, multimodal. So if one news gathering fails, it doesn't affect the other news sourcing accumulation tasks or agent. So you just lose maybe one branch of it. Maybe you lose the video branch, but you have the textual, the social media, and. Or customer service. You can specialize here, have a billing agent, you have a technical support agent that is only optimized for the technical support of your specific, I don't know, system, computer system. You have a general inquiry agent that can handle all other types of questions, general intelligence, content creation, education. Yeah, this is nice. You teach different subjects. Now, for example, you can have agents that are specialized to access specific, let's say, mathematical tutor agent. He can connect to, let's say, a dozen different mathematical sources, books, textbooks, databases, exam questions, trial and error questions, whatever. You have history tutor agents specialized on their sources. When they build up their local memory, they know what you know, and they know how to build up on your knowledge. Science tutor, you get it. Research, project management, everything. Risk management agent, clear. Okay, furthermore, by having each agent specialized in a specific task, you reduce, of course, the risks. Each agent can be finely tuned to its specific task. You give access to different APIs. You can create your own set of rules, what to do if something happens. If the format it does not fit, you do this action or this action. You can provide guidelines, strategy. You can have some complex decision path. Overall, it leads to a better performance, a better user experience. Instead of multiple GPT-4s, yeah, this was a question of one of my viewers. I said, hey, can I have multiple GPT-4s that interact with each other? And I told them, hey, just wait a little bit, I will show you. So you do not have multiple GPT-4 machines, but you have multiple GPT-4 instances with your specific agents. But remember, you have to pay it for each instance. So there's no way to get it for cheap, this piece of information. Yeah, remember, if you have multiple agents that interact, complex, are dependent on each other, you have a specific interaction pattern. This can get complex real fast, real soon, and you have maybe some errors you're not aware of at the first time. So make sure that they run effectively and that you are not overwhelmed by the complexity of the interdependencies of all the agents you create. Yeah, I will show you a simplified real-time or real-life example of multi-agents LLM. Again, if you want to find here the complete detailed coding here, I just recommend API OpenAI.com version 1 chat completion endpoints. Have a look at this and create a model response for a given chat conversation. There's also here the platform OpenAI.com docs, the API reference documentation for chat to create this. Here you have the explicit code you can string copy and have all the different modalities thought about. I will just show you here an abstract simplification that you see how we can build here a more complex real-life example just for fun. So let's say here we have OpenAPI key or a credit card already, and we define here the class of a general agent. Now this general agent has some options. He, she, it can create agent, can hold agent, can activate plugins, use plugins. This agent can generate a response from GPT-4, or here we use ChatGPT, the June 13 edition that is able to operate with function calls. We have specific messages from the system. I tell him, hey, GPT-4, you are now I don't know, mathematical tutor or whatever. And then I say, hey, I was a user. I have here my prompt. And I say, help me with integrals about polynomials. And then we can define here a function, this new OpenAI API functionality. And you can define whatever you like. This is just a very simplified thing that you say I have an input schema with a string, with a prompt here, and I have an output schema with a response of the system. And then you take here the assistant, so the GPT-4 message, and you return the message if it's not none or else or incompatible or whatever. And then we have the ability, as I showed you, to create an agent. And we take here, for example, here, the ability, the general agent definition, that we say, we give it a specific role. Now you're a history teacher. Can it create agents? Yes or no? It's a Boolean operator. Can it hold agents? Yes or no? Can it use plugins? Yes or no? This is maybe important for your credit card bill that you're going to receive later on. And you take care about exception. There's not yes, yes, yes. And you hold agents. You get it, what I'm trying to show you. And then just to show you the complexity, let's say we have here a discussion between two people. And we have one person is more of an emotional argumentation pattern that he follows, and the other person, she is more of a factual person, arguing with data and factual things. And then, since this is an official discussion, maybe broadcasted in TV, you have a moderator who moderates the whole discussion here. So we have here our general agent. We give this agent now a specific role so that GPT-4 knows exactly what it has to perform. And the task, we can tell him, hey, you are now a moderator. You can create sub-agents and you can stop sub-agents. And so let's go there. Where are we? The plugins that are available that you have access to, for example, is emotional language generation, sentiment analysis, fact-based language generation, logical reasoning, or whatever you have. Or you can even link this to a subsector of GPT-4 that you say, and you are now a specialist in time management, or you are now have a PhD in introducing complex topics in sociology or in human psychology or whatever. You get the idea. So we have here our first discussion participant, our second participant, we have the moderator. And then, as I told you, each agent that is simulating now this discussion can create different other agents. Let's say you want here, if you talk about emotional topics here, that you want to have here a rhetoric agent that is specialized in the perfect rhetoric for a specific audience group and a specific age group. You know who are your, let's say, voters that you want to address here in particular, or maybe there's a minority that you want to address here in a discussion. So you know what rhetoric you have to choose in your emotional argumentation. So we create here an emotional agent, and yes, it has to be persuasive and rhetorical generation and beautiful. And the other person says, hey, I need an online fact checker, a real-time fact checker. So you create an agent that is connected to, I don't know, fact checking APIs, whatever you have. And then you can have other agents that are created by sub-agent, you counter-argument and timekeeper agent. And you see, now we have defined quite a lot of agents. And then you have to define a turn-on-turn a discussion schema, how those agents interact. You can have that participant 1 can make a statement and then participant 2 answers. And then it's the turn for participant 2 to bring up a new topic and participant 1 answer. So whatever interaction pattern you define in this computer simulation of a real world discussion between two people, you define it. Or you say, hey, I have a one-on-one turn for 3 times and then I have the moderator summing it up or changing the topic or however you define it. Let me show you this maybe in a visualization. I think it's a little bit more self-explanatory. So here we are now in a simple symbolic depiction of our system. So we have now our multi-agent GPT-4 system for social insights in, let's say, a presidential election coming up 2024 in a hypothetical country. So we have a candidate 1, we have an agent, and a candidate 2 and an agent, and we have a moderator. 3 simple agents. So what can we do? Now, let's think about this. Candidate A, let's say, has a particular characteristic. Let's say his argumentation style is defined by emotional triggers in his statements. So maybe we have here then another agent, let's call him an emotional trigger agent, that tells us, hey, in a discussion, what is my next best emotional trigger? You can connect to OpenAI API, get access to GPT-4, and see how you should formulate an emotional trigger. Let's say candidate 2 here is more based on factual information. Would like to argue here about factual data, about what you can fact check. So you have here also an API to OpenAI, GPT-4, let's say the same example. And you have now an agent that is focused on factual topics that are important to a public in a specific nation. Now, given the course of the discussion, you might find out that you will have to fact check very fast some upcoming topics. So you need here, or the factual topic agent need to create a sub-agent that can connect to an external API. Let's say this external API is the homepage of New York Times or Washington Post or whatever publication you prefer. So we fact check and we come back now with the actual fact check data, with the source of the information. And you say, hey, look, you have a new piece of information to the factual topic agent that can then feed it back in an actual statement by candidate 2. Now the same, of course, is true for the other candidate. And let's say here, this candidate here creates an external API agent that has a look at social media in real time. Maybe Facebook, maybe TikTok, maybe whatever medium you have. And it's looking especially for the strongest emotions that are trending on a particular social media. So you see, you can simulate two very different agents if they have different personalities and different styles of discussion. But of course, you can have additional agents. For example, here, you can have here countermeasure agents. What happens if candidate 2 is somehow attacked by candidate 1 verbally with a statement that is not fact-checkable, but is strongly emotional? How would a person now react? What is the best way to react to an emotional attack if you are, and with your personality, more on the logical, factual side? You can design a countermeasure agent that counters this emotional confrontation and ask OpenAI, here, let's say GPT-4, how to best counter-argument an emotional statement. And of course, exactly the same on the other side. You have here an emergency agent. If you somehow notice, oops, we are running into some troubles, you have an agent that has access to a document. Maybe in this document there's a list of specific points that you as a candidate 1 want to stress in your presidential campaign. And you say here, first topic, second topic, third topic. So this emergency agent comes up and say, hey, I have the most important point now that you have to stress. So you see, the way you build your agent, the internal logic, the internal circuit of argumentation, you can really design this. Yeah, of course, the moderator agent, you can have, for example, that it snaps into place after 2 times every candidate 1 and 2 had 2 statements, and then the moderator comes in. Or you have a moderator that is listening to the conversation and acts only on specific word triggers. For example, if it hears, I won the 2020 elections, then maybe the moderator has a path of action to go forward. Let's say here in a hypothetical world where this moderator is simulating Fox Entertainment, a hypothetical corporation in America that just paid some amount of money. They say, oops, we want to make here a statement, whatever it is, whatever the moderator can now interact with. So you see, the system here is perfect for simulating different runs. So let's say, just an idea, after 100 computer simulations, where you have exactly this phenomena of a presidential discussion of two candidates represented by agents that have very distinct characteristics in their personality. And they simulate now, as an agent, this real person characteristics. After 100 simulation, you know what is the optimum chain of discussion. If you get an emotional argument, how to counter this. If you got a factual argument, how to address now certain emotion in your audience. So this here is of real importance to the real world in the upcoming near future for a lot of nations, for a lot of countries here on this planet. And you see why here social insights is so important, and the power of OpenAI APIs And remember, the intelligence behind all of these boxes, except now where you have an external API, where you go to the New York Times, Washington Post, or whatever you have, it is GPT-4 or ChatGPT. Whatever are your computer simulation, there's more or less just one company, OpenAI, with a system intelligently enough to provide real social insights. But we will focus here on the compute or on the code implementation, and to have here professional code implementation, maybe in the next video. We will talk here about some clever ideas from very clever people here from June 5th, 2023. Here's an author preprint about multi-agent collaboration. How to harness here the power of intelligent LLM agents, and they design a new multi-agent system with enhanced capabilities. So there is some very interesting research going on currently, but to discuss this paper and this new coding methodology would be a little bit too much for this video. I hope it was informative. I hope you enjoyed it, and it would be great to see you in my next video.